lot of the work up until the last 3, 4, 5 years was, we write the code and we hand it to some operations team and they take it, right? The cloud's changed that, right? And so as engineers and as architects and as application developers, infrastructure as code and understanding that side of the world has become more important for us, right? The last 3 contracts I've been on has involved this, at a high level. So it's not so much anymore we can just be developers and we're going to let somebody else worry about all these other issues, right? So that's kind of the impetus of this. I know that a lot of you have dealt with infrastructure as code and thought about these things through Terraform and other tooling. We're not really going to talk about, I'm not going to get into a comparison a whole lot today. That's really not the point. I just want to kind of, we try to do these tech talks every 4 to 6 weeks-ish. And it's really just an introduction or something, right? Because we got folks in the house that this will be brand new to. And I also have folks in the house that have probably used this more than I have. So with that said, feel free to chime in with opinions and experience and things that lend to the conversation without going too far with it, right? Because we got to get through our introduction today. So speak if you want, but I may tell you to be quiet. Just kidding. So let's share a screen here and get rolling. So I have a small slide deck that I want to use just to sort of introduce these topics, and then we'll get into some hands-on and look at some code and make some things happen in a real simple sense. And then if we have time at the end, we'll look at some Terraform Cloud and how we'll collaborate, how potential collaboration could happen. And then I got some more complex examples if we got lots of extra time. What is Terraform? Why would I use it? And how does it work, right? We're not going to get super deep into all the complexities of how we're going to solve every problem in the world, but this is the primer. I found that when I learned this, that the Terraform documentation is really good. But like a lot of technical documentation, it's written from the perspective from somebody that really knows how it works. They have so much intimate knowledge of they kind of leave some of the basics for you to kind of figure out yourself, right? And so it can be a little daunting to understand sort of the architecture and the basic kind of primer pieces. And so that's what I want to close today, because their documentation is better than anything I could put together, right? Once you kind of understand where to go, how to use it, what it's doing. So that's really the goal for today. So first question is, what is it? That sentence on there looks like a lot like something you'd find right off of their front page of their site, right? So I kind of broke it down into these 3 pieces. This is how I think about it. It's infrastructure as code, right? So really what we want to get away from is the days of configuring infrastructure in a manual way and in a non-repeatable way, right? We want to be able to repeat and rely and have consistency with the way we do this. We want to be able to version control it. We want to be able to look at history. And most importantly, we want to be able to blame someone, right? Because that's what we like to do. We like to have blame and gets good at that, right? We can look at who did what and blame them for it. The second piece is it's declarative. All right, so I think a lot of us, or most of us, probably know what that means, but it's a different way of thinking about the way of solving problems, right? The declarative world says what you want to do, not how you want to do it, right? And we want to write our configuration in a declarative syntax. We'll talk a little bit more about that in a minute. Next piece is it's workflow driven. So the Terraform product or software itself has an inherent workflow and how it's intended to work. So we'll look at that a bit, okay? So last, or real quick on the declarative versus imperative conversation. So the imperative approach focuses on how you do something, whereas the declarative focuses on what you want, but it's not a step-by-step of how you get there, okay? So when we talk about that in this context, we're saying we want to write configuration that defines an end goal, right? It defines the desired state that I have for some infrastructure and its configuration. But I'm not going to write specific API calls or CLI shell scripts that execute that, right? I'm really defining the end goal, and something else, in this case, something else being Terraform and its core product, is going to take that declarative code and make it look that way, right? So that's really the difference. I've heard it described, and I kind of like this, that an imperative approach would be like a remote control, right? A remote control is automated, right? I can sit on my couch and I can change the channel, I can change the volume, I can say I want to record, but everything I do is a specific command to have that thing react the way I want it to react. If my wife grabs the remote, she's going to change it to some other channel and turn the volume way down because I can't hear, and and probably do other things that are outside of my control. And when I get it back, if I want to get back to where I was, I have to repeat all of those commands again. Change the channel back, change the volume back, whatever she changed, I have to redo that, which I can do. But I haven't defined an end goal. I haven't said, well, I want the volume always to be at this level and the channel to be here and that, right? So that automation is imperative. Whereas in the declarative world, it'd be more like a thermostat, right? Where I say, I want the temperature in the room to be 72 degrees, and I don't care how you get it there, whether you got to turn on heat or air conditioning or whatever you got to do, just keep it 72 degrees, right? So that's kind of the way I like to think about it. I didn't make that up. I heard that from somebody else, and I thought it was good. So next question is, why would I use it? Source control configuration is the first bullet, right? I want, as we talked about on the first slide, I want to be able to look at history, understand the changes, and then the second bullet, using that source control configuration, have consistent, repeatable results, right? So I can do this thing over and over and make sure that I'm achieving the same thing all the time. And the second half of that is potentially across multiple environments. And this is where I see the power, the real power in this is, we've all experienced the dev doesn't look like test, doesn't look like prod, right? No matter how many times they configure the VM to look that way, there's always something wrong, right? We want to eliminate that problem, get rid of the it works in my environment problem, right? And have that repeatable across environments, and always end up with the same results. It codifies. I looked at that word. Is that codify or is it codify?
I've always heard codify.
Oh, I've been saying it wrong the whole
Yeah, I've heard both, and I felt like codify, but then I thought I was wrong, so I said codify. So we'll say codify. It's going to codify our cloud APIs into that declarative config. All right. So that's a lot of words, but essentially what I'm saying there is we can, if we're talking about, let's get specific. If I'm talking about provisioning on AWS or Azure, right? I can use the AWS CLI or the Azure CLI, and I can script out the way I want configuration to happen, right? Shell script, just in my terminal, right? I have an automated remote control way to make that thing respond the way I want to, right? But I can't really, if that API changes over time, that breaks my scripts, right? I haven't really defined what I want. I've defined how I'm going to do it, right? So in this sense, it's really black boxing those APIs that I'm going to deal with on the back end, giving me a configuration language and then something in the middle, right? We're going to talk about what that something is that Terraform provides that's going to codify, right, our cloud API and take care of that for us. Now, if the API changes, my Terraform stuff in the middle, which we'll get into, may break, but I got one place to fix it, right? I've got that one API layer that I can fix it, and all of my configuration now works again, right? So it doesn't fix the world, but it certainly makes it easier to manage. Simple and human readable, right? That's important. I'll let you guys, when we get into this, judge for yourself how simple and how human readable it really is. But I do think that once you understand their architecture and their basic constructs and data types, it is simple and human readable, right? Day one, I looked at it and said, I have no idea what this does, right? It doesn't make sense to me. But after you use it for a while and again, understand the constructs, it makes perfect sense. And it's API agnostic or provider agnostic, meaning that I can use Terraform to configure to AWS, to Azure, to Google Cloud. And it's not just for cloud provider configuration, right? It could be higher level things. I could be configuring Kubernetes. I could be configuring EKS sitting on top of AWS. I could be configuring Auth0 as my auth provider, right? Anything that's got an API, I can use Terraform to talk to it. There may or may not be what's called a provider, that stuff in the middle that I told you I'd talk about, that does that yet, but I could write my own providers too if I want, right? And hide that API magic behind their provider architecture. Does that all make sense? Happy so far? So next question then is, how does it work? And I've learned over time that people like pictures. Some people like pictures. Some people like words. Some people like code. So I'm going to give you all three today, right? So this is the picture version of how this works. You, the user or the practitioner, are going to write some infrastructure as code, right? You're going to write some configuration. We'll look at what that configuration looks like, but just talking about the basic high level, how it works. I can write that code all on my own, or I can use stuff that other people have written out of the public module registry. So there's things that other people have contributed both officially through Terraform and through community, it says there, right? So I can grab other people's solutions to things. Once I've got my infrastructure's code written, I want to plan it. This is like a preview, right? This is a dry run kind of thing where it's saying, I see what desired state you said you want. It's going to, during a planning phase, say, here's what's reality, and then it's going to show you the difference. If you run this, this is what's going to happen. You're going to create these three you're going to create a VPC with 3 subnets, and in those subnets, you're going to have these security groups, and you're going to drop these EC2 instances onto that VPC, and you're going to create this many elastic IPs, whatever it is you said you want, right? These load balancers, it's going to look and say, this is what reality is. This is what you said you want, and here's the difference. And it's going to show it to you. So that's the planning phase. Once you've done that, then you're going to go to an apply phase. It's really make it so, right? Do the things you said you're going to do. I did the plan. You said you're going to do these things. Now apply it and make it happen, okay? That apply really then is using what's called providers. Okay, that's stuff in the middle that I referred to earlier. So it's looking out at the providers that's configured within that infrastructure code up here at the top, and it's saying, how do I actually make that happen? This is not stuff we write typically. This is stuff we use, right? Either from Terraform's official registry, stuff they've released, or from community or third-party modules, okay? Once those providers do their work, I end up with the infrastructure that I wanted. Okay, that's basic flow in pictures. If we look at that same sort of process, both from a CLI and an explanation in Word standpoint, basically I'm going to start off once I've written my code, and I'm going to do a Terraform init. That's going to initialize my directory. It's going to pull all the providers down by version that I want. It's going to do some initialization of backend stuff we don't really care about today, but think about it as sort of the yarn of the Terraform world, right? I'm running a yarn install or an npm install. It's grabbing everything that I've said I'd need from a configuration standpoint, bringing it down into the runtime environment so that I can use it, okay? I can run it over and over, but once I've done it once, if I haven't changed any of my provider or backend information, it's idempotent, right? It's just going to do the same thing over and over. You have to run it at least once, but you don't have to run it every time once it's been done. From that point, I'll do a plan. All right, and that plan does what I said before, is it's looking at the difference between the desired state, what I said I wanted through my configuration, and the current state, what's actually living in that world, whatever world it is I'm trying to configure, okay? And it's going to report back those differences. Then I'm going to do an apply. Basically, that's make the current state match the desired state, right? So it's going to actually do the work. If we look at it from yet another view, this is the sort of the architecture and workflow view. Is I'm starting with some configuration down here in the bottom. Actually, I think I have some highlights on this one too. I do. Look at that. Start with some configuration, and then this is something we haven't talked about yet. Then it's going to look at current state. So Terraform, one of the things it does is it keeps track of the current state in its, and I'm going to say local environment or runtime environment, wherever I'm running that Terraform action from. Okay, it's going to keep the current state that it knows about. Obviously, the first time I run any kind of Terraform plan, it knows nothing, right? Because there has been no current state to this point. It's created nothing. All it has is that configuration file. So the first run, that's going to be empty. But it's going to look at that combination of the configuration and the current state, and it's going to hand that off to the core API of Terraform. So when I ran those Terraform Plan, Terraform Apply on the previous slide, that's really the Terraform core monolithic API that they give you, right? It's the runtime. That's going to look at that current state, and it's going to do that difference calculation between what it knows is current state and what's reality, and then it's going to kick off the work over to a set of providers. These providers are really just plugins, right? Think of them like plugins, where the real API work that's going to happen to actually communicate with that environment is behind that, right? And ultimately, I end up with my provisioned infrastructure, whether it's AWS, Azure, GCP, or again, higher level things, right? The thing I always thought about this kind of stuff is it's only really needed for true infrastructure or cloud provider type provisioning when I can use it for anything. Okay, anything that's got an API, it's a option. Let's dig into providers a little bit deeper. So I kind of said this, but it's really providers are plugins that interact with those APIs, right? So you can think of a cloud provider APIs, SaaS provider APIs, any other API that is out there could be done. Does that mean there's a provider for every API? No, but it means there could be, right? Providers are like plugins that we could write our own providers. Each provider adds a set of resources and data sources that Terraform can manage. So these are the lowest level critters. I like to use that word in every presentation. Critters that we care about in the Terraform world. So a resource is really saying, this is a thing I want to provision. Okay. So a resource, in fact, I think I pasted some over there on the right. So this is a picture right out of their provider library where it would be things like an ECS service, a cluster, a tag, a capacity provider, a task definition, right? EC2 instance, any kind of thing that I can provision in any world out there can be a resource, right? So when I in Terraform say I want something to be provisioned, I'm going to define a resource. That resource is provided by the provider, which is maybe why they call it a provider. Just thought of that. So does that all make sense? Mm-hmm. So this provider really it defines a set of resources that I can provision. It handles all the API work on the back end to actually do the provisioning for that type of resource. And I just have to configure my resource based on the options that it gives me. Okay. Data sources are much the same way, but it's basically saying I want to dynamically look up something before I can use it. And I'm going to use that in my example. So for instance, if I wanted to provision an EC2 instance, one of the things I need is an AMI, right? I got to say, hey, EC2, I want you to run on this Amazon machine image, right? I can either statically define the machine image I want to use, or I can dynamically look it up through Terraform, right? And I would use a data source to do that. We'll look at that in code in a minute. I already said that last note down there, so just keep that in mind. There is a registry. In fact, I'll just click on this link. There's a registry out on Terraform where you can look up every provider that's available currently that they know about, right? So obviously these top level things are our infrastructure as a service or cloud provider platforms. You see Kubernetes sitting in there. There's a whole gaggle of things. There's 1,425 of them in their current resource. So if I go out here and look, right, I can come here and say, this is something that David actually sitting over here and I have tinkered with in the last few weeks is auth0 configuration through here. So there's providers or auth0 to do that sort of configuration. If we have time at the end, we'll look at some more detailed examples of that kind of stuff.
Quick question for Jay.
Yeah.
Is there a way that somebody that wanted to craft their own provider, they have a template for that to do that? Or do you have to kind of go through their process like an onboarding with Terraform themselves?
I think I actually haven't done it, so that's
Okay.
a great question. But my understanding is it's sort of template driven, meaning
Okay.
there's a basic format you have to follow, and then you write your code within the boundaries of that format.
Sure.
But I actually haven't done it. Has anybody else done it? Anybody online speak to writing your own providers? It's a great question. Something we can.
Yeah, I haven't done that, but I'm pretty sure it's just create those kind of providers by yourself instead of deal with the Terraform in this case. I mean HashiCorp in this case. Yeah.
I don't think they wouldn't necessarily want to get involved. You can probably create it yourself and publish it, and they do have. If you look over here, you kind of see this. Let me make this a bit bigger. You see, they have verified. They have official, verified, and community. So I think this verification process is probably some, like you're alluding to, some process you can go through with them to verify that this is sort of quasi-official.
Open source, cost, and licensing.
All three. Open source for use completely. They do have an enterprise model that you can pay for, and you get some features. If we have time at the end, we'll look at that a bit. They have something called Terraform Enterprise, has a cloud solution where you have console and does all sorts of collaboration tools, right? Because that's a big piece of this, and I'm not really going to talk about today, is the collaboration side of this. How do Brad and I work together on infrastructure, or how does a large team work together on infrastructure and manage that state across multiple environments and dev machines and people committing code to that repository. How do we handle that, right? All that's sort of built into their enterprise model.
Your current project, you go open source model and move, when would you go enterprise?
We probably won't on the current one, but I would say at the point where you've got multiple teams involved in the overall architecture and infrastructure configuration, like Terraform Enterprise for sure. Yeah. So let's go back to our slides. So that's the registry where you can kind of, hey, is there something out here that works for this specific technology that I'm dealing with? You can go there and search and find it. And honestly, if you just do a Google search for Terraform / whatever, you'll find what you're looking for typically. So this is the code version of how it works then. So if we look at this example configuration file, you'll see lines 1 through 8 or 1 through 8 here at the top. This is basically defining what providers I need or I'm going to use in this configuration, all right? So it's always going to look like this with a Terraform block and a required providers block. And then you see inside of there, I've said I'm going to use an AWS provider, and I'm using version 3.59.0. The little squiggly angle is much like most semantic versioning systems where I can say, I want to allow, how firm am I on this version, right? That little squiggle greater than sign is accept patches, right? It's the fuzzy, I can go 359.1, 359.2, but I'm not going to go to 360, right? I'm not going to upgrade on a minor version, only patch level stuff. Next session then is defining the provider. So I've told it which providers I want to use in the first section. Now I'm defining the provider. And when you define a provider, you basically have to give it a whatever required parameters it has, right? So it's saying here every provider will have a list of required options and optional options, right? Is required options a real thing? Because it wouldn't be an option if it was required.
You just have to pick one, but you have to pick something.
Yeah, so it has a list of what's required and what's optional. How's that? Is that better? So in this case, there are actually more required options, required selections needed for AWS, but there's also often the case where you can include those in environment variables. Things like my AWS access and secret key, for instance. I wouldn't want to put those in my repository for everyone to see, right? So there may be options like that are needed, but you don't have to necessarily put them in your configuration. So in this case, I'm saying I'm gonna do all my work for this plan that I'm working on in the US East 1 region. And then I define all my resources. So remember I said provider defines resources. So the AWS provider on line 10 provides a AWS VPC resource that we see on line 14. And its required parameters, I got to give it some CIDR block, right? I actually think there's more required parameters than that. I just didn't want to put them all on the slide, but you get the idea. So I'm saying I want to create a virtual private cloud over this CIDR block, and I'm going to define that. I'm going to divide that CIDR block over across subnets probably eventually, right? But in my simple example that fits on one slide, this is all you get. Okay, but that's the basics of how a configuration file looks. I define my required providers, what provider I'm using, and the basic parameters that it needs, and then I define all the resources, the things that I want to create. Okay. Demo time. How am I doing on time? Half hour, perfect. All right, so I'm gonna give you a little bonus lesson here. And I'm guessing a lot of you have done this already or seen this, but I'm guessing a lot of you haven't. So I'm going to open VS Code on a repo here. And when I do that, you're going to see that down here in the bottom right-hand corner, it's going to pop up and say, hey, I noticed that you've got a dev container configuration in this repository. Do you want to reopen in a container? Okay. And I can come here and say yes. And it's going to reopen my VS Code in a Docker container. One might ask, why would I do that? Good question. Why you would do that is it's back to the old it works on my machine problem, right? So this is something that Luke Patterson actually, I don't know if Luke's on or not, but he turned me onto this a while back, and it's changed my life. It's changed my coding life, nothing to do with personal, but definitely made my life better. And the idea here is that, you know, if you think about any given project we work on, you know, there's often a README that says, you need this version of Node, you need this version of the AWS CLI, and in this case, you need this version of Terraform, and you need, you got to install all these, go through this checklist of things you need to do, and at the end, hopefully it all works, right? And forget about the whole, David's working on a Linux machine, and I'm working on a Mac, and Corey, this is my current project, is working on a Windows machine, right? So you got to have the special rules for if you're on Windows, you got to go do this. And if you're on Mac, you got to go do this, right? We want to get rid of all that. That's what this does, okay? So if you haven't used dev containers, I highly recommend it. I'm not going to go into this, is not today's talk, but if you look up here, recognize that because I have a .dev container folder up here in the repo. In here, I've got a Docker file that says let's get rid of this, says, here's the container I want to run in. In my case, I'm starting from a Microsoft-based VS Code dev container. This is an Ubuntu focal image. I'm adding some stuff, git, curl, unzip, bash completion, anything that I would want in this environment, I can add here. In this case, I want my Terraform CLI because I'm going to be doing Terraform stuff. And I want an AWS CLI because I'm going to be talking to AWS through that AWS provider, right? So the long and short of this is when this opens up and I come down here, is that seeable? If somebody needs me to make this yet bigger, holler. Otherwise, I'm going to leave it alone. So if I come here and say LSB release A, look what I am. I'm an Ubuntu machine running Ubuntu 20, right? I know those that aren't in the room can't see this, but I'm on a Mac, right? So my terminal inside of VS Code is an Ubuntu running in that container that I've told it I wanted to build right here, right? All of the tooling that I said I want is there. Everybody's running the same version. Gets rid of the it works on my machine thing. One caveat, I had no issues for a long time. This week we did run into one small little thing with Corey where something's not working. I'm still not convinced it's the container, but we haven't ruled it out yet. So mileage may vary, right, is my caveat there. But in a general sense, works great. We've had no issues with it. Windows, Mac, Linux, otherwise. All right, that's it about that. So dev container, moving on. So I am sitting here in my dev container. This is a This is a Terraform structure. And one thing you'll notice over here is that I've got a bunch of .tf files. Okay, so anything in a directory with a .tf for Terraform file, Terraform recognizes as configuration. And when I go to init, plan, apply, it will look at those things, right? Whether I want it to or not. So if you don't want it to look at it, it can't be named .tf. The structure otherwise is, I'll call it unprescribed. Okay, so I could literally take everything I want to do and drop it in one Terraform file, much like I could take every Java piece of code I ever wanted to write and write it in one Java file, right? I could do that, not the best way to approach life, right? So keep that in mind. There are sort of, I guess, best practices, or as I've sort of understood as I look at other people's Terraform code, especially as I look at provider-provided samples of code, there's sort of a prescribed or a unwritten rule of these are the kinds of files we're looking for. And that's sort of the path I've taken, where I've got a main file that sort of is my bootstrap first place to look. Then I've got other things, right? My other things in this case are outputs, data, variables, versions, etc. Okay. So let's look at this real quick. So if I start at the main, you'll see that I've defined a provider here. But I did not, much like on my last slide example, tell you what version of the provider or anything I needed to use, right? That's living down here in versions.tf. So if I look down here, it basically looks like exactly what was on my slide, right? Terraform, required provider, I'm using AWS 359, okay? I also did this to point out that Terraform is really good at understanding the dependency tree. What has to be done before what? Okay, most of what you're going to do is inherent into the project or into the provider. So if you say, hey, I need to go create a VPC and 3 subnets, and in those subnets I want to tie whatever, I'm going to create a NAT gateway on these 3 subnets. Well, they have to be created in VPC subnet NAT gateway order, but I don't have to specify that when I do it. Okay, that provider knows this is the dependency tree and it takes care of that for me. Okay, so that's why I don't have to worry so much about how I divide my files. I don't have to say, well, run this file first, then go run this file, right? It figures that kind of stuff out. There are cases where you create your own dependency because of the way you've broken your provider workload up, or maybe it's disparate providers where I'm running part of a workload here and this has to come after that. There is a way to say specifically this depends on that, okay? But that's sort of special case. That shouldn't be the rule, that's the exception, okay? So I specified my versions of things. I specified that I want to run provider. Unlike my slide, I'm using a variable here called region, right? So rather than hard coding a region, I want configuration that can be used across multiple environments, right? I may provision things in the East and the West and in Europe, right? So I want to be able to use the same configuration and just specify that through variables. So that leads me to a variables file where I define all the variables that are possible for this configuration that I'm creating. I have a region, I describe it, default. It's always going to look like this. I don't have to specify a default if I don't want, but I can, okay? We'll talk a little bit more about that in a minute. Okay, so I can reference those variables just through var region. And then I define the resource I want. In my case, I'm saying I want an AWS instance, and this AWS instance in Terraform provider language is an EC2 instance. And I want to run Ubuntu. This is just a name. I can call this Jaime, okay? Just a name that I can refer to it later if I want. And I'm saying I want to use this AMI, and I want to get the AMI from some data. I don't specify a hard-coded or a variable here. I want to look it up, basically, is what I'm saying. And I want this instance type based on variable, and I want to tag that instance with these things, right? It's going to have a name based on what my variable is, and it's going to be have a tag for the Linux distribution that I'm running. If I look at the data file up here, this is where I'm defining that data. So let's put these things side by side here. I think I struck out. I did. There we go. So over here is my reference to my data. Here's my definition for my data. So notice it's data, AWS AMI, Ubuntu. Data, AWS AMI, Ubuntu, and I want the ID of it, right, as the variable. So this is going to look up my data, basically saying I want the most recent AMI owned by this person, filtering down on this name that has an HBM virtualization type, right? So I can be very specific, or I could be real casual and say this any old image will do, right? But in my case, I'm just using this as an example of how I would use a data structure to look up something. This piece right here is equivalent to, reload, probably gonna have to log in. If I go over to the AWS console and I filter this down on I want to search for this Ubuntu image owned by this person with this virtualization type, right? I get this list of things, most recent's at the top, right? That's the exact same thing I just did here programmatically through this data structure, right? So I'm just looking up an AMI and then referencing it here, okay? Not really super important for what we're saying. I'm trying to get across the constructs of how I can create things and refer to them in other places, right? Through these variable constructs, through these data constructs. Once this instance is created, I might sit those instances behind a load balancer and need to refer to those things for some reason, right? So every resource I create takes input parameters, but also gives me output. This is what I actually created, right? Because I'm not going to specify when I tell this thing to create, I'm not going to specify every possible thing that ever could happen. Some of that thing is figured out by AWS on the back end, right? So let's look at this.
So does that allow you to do dry runs?
Yes, so we're going to do that now. Nice question, John. So Terraform init, basically it's going to go through, initialize the back end, initialize my provider plugins, and so on. We're not going to talk about back end today, but it's a collaboration issue, right? Well, another topic for a different day. But once it's initialized, I could run it again. It's going to look like the same thing happens, but nothing changes, right? So it's, again, idempotent. If I come here and say Terraform Plan, it's going to look at the plan, the configuration that I wrote, and it's going to basically do what I said. Look at the current state, go out and look at the AWS East 1 region and see what's there based on, is anything there that he told me he wanted? And give me the difference. In my case, notice it says 1 to add, 0 to change, 0 to destroy, right? I need to make that a little bit bigger. I see some squinting going on. There we go. 1 to add, 0 to change, 0 to destroy. And if I scroll up through here, you'll see all of this stuff. And it's saying, I'm going to go create an AWS instance called Ubuntu. It's going to look like this. It's going to use this AMI looked up from that data source, right? That's the AMI ID that I looked up using that data construct. Look at all these other things it's then going to know. What's the ARN? What's the public IP address? What's the availability zone? What's the CPU core count? All that's known after apply, right? I could specify some of that if I want. If I have hard requirements, so this has got to look this way and that, I can specify it. But there's a certain set of things that I have to give it to create an EC2 instance, and other things can be calculated, right? That's what this is showing us. It's going to create tags. It's going to create this. All of this stuff's going to come back, and so on, right? So I just did the plan. If I clear that and do Terraform apply, before that, let me make sure I show you there's nothing up my sleeve, nothing behind the curtain. So here's my AWS US West 2 region. And you're going to say, well, was it your default East 1? Right? So we go back over and look at our code. I can also specify default variables that override my defaults, right? So I can have a module that defines defaults, but then I can have a plan that overrides those. Okay, and this becomes important when you get into a collaboration mode and you want to use this across environments. But the idea here is, let me close this so I end up on one screen. There we go. Here's my region, instance type, and instance name that I'm going to use for my variables. And I've defined those in something called TF-vars. Again, a magic extension that Terraform knows how to use, okay? So if I come down here now and say Terraform apply, it's going to actually do that plan again, because there is a way to do a plan and save the plan results and then apply it immediately. In my case, I didn't want to do that because I just wanted to show you the plan. Actually, I didn't hit enter. I didn't hit enter the first time. Sorry about that. So here it is again. Basically ran that plan. It says, here's what's going to happen. Do you want to do it? Yes or no? Only yes will be accepted to approve. Yes. It's going to go through and create that stuff. So now it's going to the provider. It's running the provider logic. The provider logic's going, hey, this is AWS stuff. He's going to call the AWS APIs to create the stuff on my behalf.
I assume there's a way that you could just do the Terraform apply with a Y override, or do you have to do an approval every time?
There is. There is an auto, I don't want to be involved option. Yeah. This will take about 30, 40 seconds on average to create my EC2 instance. So there it is. One resource added. This is the kind of result you get. Notice it dumps out some output here. This is coming from my outputs file. What do I want you to output at the end so that I may be able to use it elsewhere, right? What things do I care about? So that's defined in my output. Okay. If I go over to my EC2 or to my Amazon console and refresh, you see there's my EC2 instance with an instance ID running a T2 micro. And if I click into it, you'll see the AMI ID is the AMI ID it looked at, right? If I want to change this, how am I doing on time? 15. Okay, I got 15 minutes. So that's sort of basic 101 how it works from the from scratch. Obviously, we're going to have workflow involved here, right? Over time, my infrastructure is going to change. I start with a dev environment, then I want a QA environment, a prod environment, or I start with, I'm running EKS with 2 worker nodes, and now I need 3 worker nodes, or I need to add auto scaling groups, or I need to change DNS, right? Whatever it is that evolves as the application and project evolves, I want to do that here, right? I could obviously come out here to the console and click on 1,000 buttons and create whatever I want out here. But to duplicate that, I got to go again. If I want to do it in a different region, I got to go click on the same 1,000 buttons and give it the same thing, right? So once you get into this world, you don't really want to eject and do half and half, right? And I'll kind of prove that here as we go along what will happen. So if I wanted to change, there it goes. If I wanted to change something here, I could come here to my variables and say, well, I want this to be called provisioned by Terraform today. Okay. Today's kind of relative, so that won't last past today, but you get the idea. So if I come here now and do Terraform apply, it'll do the plan. One of the things I didn't point out here is if you really look at the output you're getting here, notice the very first line, it says refreshing state. This is that comparison thing it's doing, right? Where it's saying, here's the state I knew about from the last run, right? And here's the state of reality in the world. So it's going out to AWS and saying, what's different out there from what I knew about? And then also the triangle of that is what's different about the configuration you just gave me, right? So it's got to marry those three things up. What you knew about before, what you want, and what's reality. And then that becomes the plan. If I look here, you'll see it's telling me I'm going to scroll down first, one to change, right? And if I look up here, you'll see my one to change is I'm going to go from the name being provisioned by Terraform to provisioned by Terraform today, right? So it's recognizing that change. If I say yes, it's going to go modify. Doesn't say creating, right? It's going to modify. And there it is added. If I go back to my console and refresh, now it's provisioned by Terraform today, all right? Not earth-shattering in terms of what we did, but the concept is really powerful, right? This is a great way to manage this kind of infrastructure. If I do the opposite of this, right? If I come here and say, I want to edit in this world, and I'm going to get rid of today, right? Now, whoever did that knows that it was done, but nobody else, right? Except for if I come here and do Terraform, oops, wrong window. If I come here and do Terraform apply again, it's going to go, hey, the current state that I have is not what's out there. The current state matches what my desired state is. I mean, my local state matches what my desired state is, but the remote state doesn't, right? And again, tells me, oh, I got one to change back, and it's going to change it back, all right? So it does fix that sort of thing. The challenge with that is if you got people that are going to consistently go make manual changes, they're going to lose them as these plans get reapplied, and it may be stuff that's valuable, right? You may lose, in this case it isn't, it's just a word, but if they created a whole new set of infrastructure that we really needed, we're going to blow it away the next time we run a plan, right?
Can you lock those at all? So it can't be updated on the web?
Only through permissions, right? You could give users, deny permission to those users to do it, but if they have permission, no, I don't think so.
So sort of like source code management, would there be a way just to pull in an update, kind of like a git pull to see what the status is out on the web if somebody did go manually change it, so you're not just blowing them away? I mean,
yes.
I know it's kind of opposite of what the principle you're going to teach.
No, and that's where the Terraform Cloud thing comes in. So let's actually move over there next. I think I got time for this. What time? I got 10 minutes. So I think this is your question anyway. If it's not, we'll circle back to it. So if I come out here to Terraform Cloud, so this is app.terraform.io. I've got an account out here. Actually, I created an account for Keyhole. So if you want in on this, it's a free account at this point that we can toy with and monkey with. You can also create your own free account if you want to do that. But essentially what I've done is under the Keyhole Software org is I've got a set of workspaces, and one of my workspaces is this Learn Terraform Basics. I don't think I said this at all, but that is the repo that I'm working with here, Learn Terraform Basics. This is a public repo in the Keyhole right here. So if you guys want to go look at what I did and play with it yourself, it's also got a README in here that tells you how to set up your remote container if you want to go through that process, how to use this, how to monkey with it. Okay, so all that's here in this public repo if you want to do that after today. This workspace over on Terraform Cloud is pointed to that repo, and it's monitoring that repository. Okay, so it knows when that repository changes and triggers plans, the Terraform Plan process to happen on commits, and that's completely controllable. What do I want to happen when these events happen? Do I want to plan and apply, Do I want to queue up a plan and somebody's going to go approve it? All of that type of collaboration work can happen here, right? If I was to just run Terraform on my local Mac and we were a team trying to work together on it, there's things we would have to do to manage that, right? Because if you look over here at my Terraform State, it's sitting here in this file, okay? This is Terraform's current belief of what's in Amazon. It's saving all that. Every time I run an apply, it's updating this file. Do you have a popcorn? Thank you. Hopefully that doesn't die before she gets back. So if we hang up, I'm sorry. It was nice talking to you guys. My battery's going to go dead. So so what we want to do is one option you have outside of the Terraform Cloud approach is to store your state remotely. You can do that through S3. There's multiple options to store your state remotely, right? And that's one of those backend configurations that popped up early in my init, right? If I want to configure a backend here, I say, well, my state's actually going to be stored out here. And every time you refresh, go pull from that state. Don't get what's here, right? That would allow us to collaborate on state. Okay. Thank you. Plug in real quick. I thought I would have plenty of battery, but I did not. So that's one option. In this world, in the Terraform Cloud world, I can store state in their system, in their cloud, right? So the default behavior of this workspace, I think, it's been a month or so since I set this up, I think, but and I haven't used Terraform Cloud a bunch, in all honesty. I don't think I had to configure state to be remote. I think it has a default setting of it's going to keep the state, and then I have options to do something else with it if I wanted, right? I could push it to S3 or some other place if I wanted, okay? But the key here is that beyond me just going and changing code, in fact, let's just do that. Is that a question or is that?
No, I think that was me. My bad.
Oh, unmuted? Okay.
Sorry.
It's all right. So let's go here. I made this change to my default vars. Let's just commit this. Actually, let's do, how can I do that without this? Because that's not really the state that Cloud knows about. Well, let's skip that. Let's just come here and say, if I want to run in this world, one of the things I can do is just come here and say, start a new plan. Right? Every time I commit code and push it, it's going to start a new plan for me automatically. And it's going to sit there in a state that looks like this. Okay, so it's triggered. This plan was queued and triggered by me. If it was triggered by a commit, it would say triggered by commit, blah, 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 right? But it's going to end up in this same place where it's going to run the planning phase, but notice the apply is pending. Okay, so this is running that same Terraform plan. If you open this up, you get the same, oh, it's this one down here. If you open this up, you get the same list of things that I saw in my console, right? Here's all the things I'm going to do. And then down here, what do I want to do? I can confirm and apply it. I can discard to run, right? There's things, and there's multiple options in here. And again, I'm not a Terraform Cloud or enterprise expert, but because I haven't used it a ton, but there's ways to collaborate here and automate this process. If I wanted changes to a master branch to be automatic, but anything develop release branches of this Terraform maybe go to different environments and they require some intervention, or maybe the opposite of that, whatever the workflow is, right? But if I say come here, confirm and apply, and confirm this, it's going to run the apply here, okay? So one of the big advantages of the cloud, obviously, is that shared state, and it hooks into my Git workflow where I can manage commits and what I want to happen automatically when commits happen, right? Versus my CLI interface I have over here. Whatever happens is what I tell happen, right? I'm applying an imperative approach to my Terraform declarative application this way, whereas on the other side, I can make it more declarative on the actual operation of it as well, right? All right. Does that all make sense? All right, last thing, I promise I'll shut up, is over here, let's go look at a more complex example. So if I open this in VS Code, and I'm not going to get super deep into this because we could literally spend hours talking about all the things that I'm doing in here. But I just want to get you, this is more of a, get a feel for what's possible and how it might look. And some of you that are more Terraform experts than I, if you have suggestions after looking at this going, wow, you really screwed that up, then let me know that too. So this is a infrastructure that's building out a huge AWS footprint. Huge is probably the wrong word. A fairly sizable AWS footprint. Okay, and if you look at the main in here, let's actually just close this because I'm not going to run it. Let's go here, here, here. There we go. So much the same, defining my provider. And then I'm using something called a module. We didn't really look at this, but modules are a way to encapsulate a bunch of resource types together and reuse them. So modules are another level within Terraform that we didn't talk about in the basics, where basically I'm saying this module defines a bunch of resources for this provider that I'm using, right? And I can reuse that module in a variable way over and over and over again. So one thing you'll see here is that I have a module called dev environment that's running out of a source tree called runtime environment. And I'm giving it dev-like variables, dev subnets, dev availability zone, dev CIDR blocks, right? Whereas I might have a QA environment and a prod environment that give it different variables, but I use the same module over and over. That ensures I get the same resources, just with different configuration from the things that need to be different standpoint, right? Does that make sense? All right, so I can only see heads nodding in the room, so I'm going to assume if you don't say anything online, you're okay. So if I look at dev environment up here, dev environment has a bunch of stuff in it, right? I'm creating VPCs and security groups and an Elastic Container Service and an application load balancer, right? If I look at VPCs, I'm creating using a module again. Actually, that's dev environment runtime. This is my new. I've been refactoring this over the last couple of days. Here's VPC. I'm using a module again, VPC, that takes a bunch of variables, right? How many subnets and what subnets do I want? All of that type of thing can be rolled up into these modules. All right. Here's my load balancer. I'm creating an application load balancer on this VPC for these subnets with these security groups, opening up these ports for these people, right? All of that can be done through here. Again, I don't expect you to understand or even care about how this is built, but this is sort of more complex version of what we did in that simple EC2 instance scenario, right? Security groups, variables, even down to the Auth0 level, right? So if I look at Auth0, this is not a platform or an infrastructure as a service thing. This is software as a service, right? I can come out here to an Auth0 login and say, I can come out here and change anything I want. I want to create these applications and these APIs and these SSO integrations, and I want this authentication configuration, right? This is Auth0 config if you're not familiar with that, right? I can do that just like I can on the Amazon console. I can change all of this stuff, right? But I can't repeat it across accounts or for another account, right? If I come over here, all of that stuff there's my APIs, here's my applications, here's my branding, here's my grants, all this stuff rolled up under a main. Here's the users and roles that I want for admins, variables and versions, right? So anything that has an API can be done this way. It doesn't have to just be infrastructure, traditional infrastructure, right? It can be higher level things. That's all I got. We have 0 minutes for questions, just the way I like it.
I have a question. Competitors to this?
Oh, good question. So CloudFormation, there's some specifics, which I probably should have mentioned right at the beginning, this is sort of a companion to something like CloudFormation. So CloudFormation is the AWS solution to this, right? So it's not any API provider can be used. This is how we do it for AWS. Azure has its Azure Resource Manager, right? Same kind of idea. So there are things like that from a sort of wide open. This would be in the realm of Ansible. Run this task, then run this task. This depends on that, right? It's much harder to unwind when you want to refactor, whereas this is completely declarative and agnostic. Dependencies don't really matter. It figures all that out, right? It's a much cleaner approach to the same problem. Okay. And there's Chef, Puppet, or configuration tools like this. Those are also a mixture of declarative, imperative kind of metaphors. So.
Great, that's awesome, man. Thanks.
Okay. Thank you.